Hello everyone, my name is Carla and I'm a senior developer advocate here at Auth0. If you're watching this video, I reckon you've already heard about passkeys, or maybe you have a general idea what they're about, but you're still looking to clarify some concepts. So we're gonna do exactly that. Let's begin. First things first, the term passkey is a common noun similar to the word password, and so it shouldn't be capitalized as like passkey or anything like that, but just like any other common noun. So it's not a product name or a technical name like ID token. The FIDO Alliance defines passkey as the replacement for passwords that offers secure, faster, and easier way to sign in to your website or your applications across user devices. But they also have a more technical definition of passkeys. They say that passkeys are FIDO credentials that are discoverable by the browser or housed within native applications or security keys for passwordless authentication. So even though the term passkey is commonly used in everyday conversation, it does define a set of technical specifications commonly known as FIDO2 WebAuthn. So I've already mentioned FIDO and FIDO2, but what am I talking about? FIDO stands for Fast Identity Online, and it refers to the initiative to solve the password problem in user authentication. This same name is used to identify a set of standards that allow the user to authenticate using cryptographic keys, although the correct name should be FIDO authentication. This is the name of the Open Industry Association that carries the Fast Identity Online initiative. Some of its members are Apple, Microsoft, and Google. FIDO2, or FIDO2 authentication, is one of the FIDO Alliance's technical specifications for passwordless authentication. More specifically, FIDO2 is the set of standards that passkeys actually rely on. FIDO2 authentication includes the W3C WebAuthn specification and the FIDO Client-to Authenticator Protocol specification. All of these together are commonly known as FIDO2/WebAuthn. Lastly, we have the WebAuthn specification, which defines how web-based relying parties can interact with passkeys in a browser, while CTAP allows the implementation of cross-device authentication. So technically speaking, we already said that passkeys refer to FIDO credentials, but what does this actually mean? FIDO credentials, also known as WebAuthn credentials, are cryptographic key pairs that are based on public key cryptography and that they are used for authentication. With FIDO credentials, the authentication process does not rely on a shared secret as it does with passwords. On the contrary, the user shares the public key with the authentication server at the time of registration. And sharing this public key does not compromise the security of this user's identity. As any public key, this is public information that can be shared with anyone. Then to authenticate, the user needs to demonstrate that they possess the corresponding private key. And this is accomplished by signing a challenge with the private key. And that challenge is not more than a randomly generated value, which from a technical perspective means that we can identify a passkey as some sort of a special FIDO credential. And you're probably wondering what is so special about this credential? And the thing is that they are discoverable. And that means that an authenticator is able to detect the private key that is associated with an authentication server or a relying party given the domain. This makes the user experience way smoother because it means that the user doesn't even have to remember their username to send it to the authentication server. So passkeys rely on FIDO2 authentication, which is composed by two standards, and that is the WebAuthn specification and the Client-to Authenticator Protocol, or CTAP2. While CTAP2 defines how devices can communicate with external authenticators, WebAuthn defines how browsers can manage FIDO credentials for registration and authentication. WebAuthn defines a JavaScript API that allows a browser to request the creation of a new passkey and also to get proof of possession of the private key. By using this API, that website cannot access the private key of the cryptographic key pair, but it can request the authenticator to sign a challenge with that private key. This is what proves that the user controls the private key, which in the end, it means that they can prove their own identity. So a passkey is a credential that allows users to prove their identity, while WebAuthn is a standard API that allows applications to use and create passkeys for sign-in. Using biometrics is one of the ways to complete the authentication process with the relying party. But saying that passkeys let you authenticate through your biometrics is not entirely accurate. The relying party doesn't have access to your biometrics. Your fingerprint and your face data are stored locally in your device authenticator. So the relying party cannot authenticate you based on your biometrics. It authenticates you as the holder of the private key part of your passkey. Biometrics are used locally to let you access your authenticator. Also, you don't really need to use your biometrics unless the relying party enforces it. You can just use a PIN or draw a pattern to access your authenticator. A user account is the representation of the identity of a user in a given context. For example, your Google account identifies you in the Google ecosystem, so you can use it to log in into Gmail or YouTube and so on. In order to prove your identity to Google when you access one of its applications, you need to provide your credentials. But this credential is not your identity or your account. It's just a way to prove that you are who you say you are. In fact, you can change your credentials, but your account will remain the same. When we talk about passkeys, you can add a passkey to your account. In fact, you can add multiple passkeys to a single account. And if you remove a passkey from your account, you're not deleting your account. You're just removing one of the ways you have to prove your identity. You can think of passkeys in this context as you would think of passwords, but only in this context. While many FIDO authenticators are based on hardware devices, FIDO2 WebAuthn does not necessarily require this. You can implement an authenticator via software, which means that the public and private key pair is created by the software, and it's stored in the file system after encryption. A software authenticator can be part of the operating system or an independent application. While a hardware authenticator does not allow you to export the private key stored in it, a software authenticator is a bit more flexible. In fact, sync passkeys rely on a software application or an operating system subsystem to export their private key to the cloud and then share it with other devices. A lot of people think that passkeys are only meant to be used for web applications, but you can actually use it for mobile and native applications as well. There are two approaches you can use to get passkey support into your native applications. One is to use the browser to authenticate the user, and one is to use the native implementation. In the first case, you can delegate the authentication process to an external browser or a web view. And in that case, the user authentication relies directly on WebAuthn, as it happens with web applications. After the authentication process happens in this external browser, the user is redirected back to the native application along with the token to prove their identity. Now, on the native implementation, platforms provide you with a native implementation approach that you can use to manage your passkeys. For example, you can use Credential Manager to support your passkeys in Android or specific APIs for Mac OS and iOS. Authentication using passkeys relies on authenticators, and this can be software or hardware components that are capable of managing cryptographic key pairs. You can have two types of authenticators: roaming authenticators and platform authenticators. Roaming authenticators are authenticators that can be used in a device other than the one that the user is authenticating in. A good example of them can be a security key like a YubiKey or your smartphone. Platform authenticators are those that are integrated into your device. Some examples of platform authenticators can be the Google Password Manager or Apple's iCloud Keychain. Although sometimes a specific authenticator can act as a roaming authenticator in one context and as a platform authenticator in another context. Think, for example, of the case when the authenticator is embedded in your smartphone. When the user authenticates in an application running directly on their smartphone, The smartphone is in this case a platform authenticator. But when the user is trying to authenticate, let's say on their laptop, and they're trying to use cross-device authentication with their smartphone, in this case, that smartphone would be a roaming authenticator. Officially, we have two types of passkeys, sync passkeys and device-bound passkeys. Sync passkeys are those that can leave the authenticator they were initially created and synced in another devices via the cloud. These passkeys are end-to-end encrypted and are synced on all the user devices that are using the same provider. In the past, they were also referred as multi-device passkeys, but we no longer use that term anymore. Now, device-bound passkeys are those that are bound to a single authenticator, which, for example, can be the authenticator that were initially created on. So once a passkey has been created, it cannot leave that authenticator, and you can think, for example, of a security key like a YubiKey. In the past, we used to call this single-device passkeys, but this is also a term that we don't use anymore. Once the authentication server has authenticated the user, whether if they're using a passkey or not, it can generate the authentication cookie just like it did with username and password authentication. So passkeys and single sign-on can coexist without any problems. Also, passkeys can coexist with OpenID Connect and OAuth 2 as well. At this point, I think we can all agree that the technology behind passkeys is solid, more secure, and just more convenient in general. But it can also be a little bit tricky to understand and therefore lead to some misconceptions. Hopefully, after watching this video, some of those misconceptions are clarified, but if you have any other questions or comments, make sure to leave them in the comment section below. And as usual, thank you for watching.